All right, number 8, we also want to graph this function. This time it's already graphed below, and we just need to choose which one is correct. We're given the function f of x equals the square root of x plus 6. In this case, you want to be aware of your domain and which numbers actually work. Sometimes if you plug a number in, it might cause it to be negative. So you want to be careful there. And specifically, I want to know what numbers when I add 6 to them, it will give me a perfect square number. So, because I'm going to be doing the square root of these numbers. So I want to know x plus 6 equals one of these numbers that have a perfect square, so that when I do the square root of it, it's a perfect square. So x plus 6, I want it to equal 1, because I know the square root of 1 is 1. Not 2, I want to use this to be 4, because the square root of 4 is 2. I want to be able to use, so 1 squared, 2 squared is 4, 3 squared is 9, and that could be good enough. So just these 3, I want to use 2 or 3 points. That'll allow us to see the pattern. So if I solve this equation, and I'm doing that because that's what's under here, I want whatever ends up under the radical to be equal to a perfect square number. So if I do this, what I would be doing is just solving a linear equation. So x plus 6 equals 1. I would subtract 6 from both sides, and that would give me x equals negative 5. All right, so that's one x value that I want to use, and then I'll do the same thing here. So x plus 6 equals 4. This is just a strategy that you want to use to help you get nice whole numbers. Otherwise, you really need a calculator to find the decimal points and see what's going on with this graph. So here I want to do subtract 6 again from both sides, and when solving this, we would get x equals negative 2, and then we'll do one more. That's 9, so I'm going to say x plus 6 equals 9. So what number do I need to plug in for x? We would subtract 6 from both sides, and that would give us x equals 3. Okay, so this time I didn't do a negative, 0, and positive. I did these numbers. I did mention that you want to be aware of your domain. So remember, under a square root, the end result cannot be negative. I've already set it equal to 3 positive numbers. It can be equal to 0 if we want it, but that's okay. We just started with the positive number, so that just helps even more. But if you wanted to find the domain, to find numbers that you could use, you would start with what's under the radical. So domain x plus 6, you put the restriction has to be greater than or equal to 0, which means positive. And then if you solve for x, that tells you that you can use any x value greater than negative 6. And as you can see, the x values that we have, negative 5, negative 2, and 3, all of those are greater than negative 6. All right, so let's make a table now. We have strategically picked points that's going to work out nice, and we're going to solve from there. So negative 5, negative 2, and 3. So if you plug in negative 5, we've already have our predetermined answer is going to be 1. And then the square root of 1 is just going to be 1. So your y value will be 1. When I plug in a negative 2, negative 2 plus 6, that's going to give us 4, already our predetermined answer. So the square root of 4 is 2. And then likewise, when I plug in 3, 3 plus 6 will give me 9, and the square root of 9 gives me 3. So I have 3 nice whole numbers. I'm just going to draw a rough sketch of a graph here, and we'll see which way this graph is trending. So negative 5. 1, 2, 3, 4, 5, up 1. And then negative 2, 1, 2, up 2, 1, 2. And then 3, 3. So 1, 2, 3, up 1, 2, 3. So it looks like this graph would be curving this way. And if I did 0, if I plugged in, I wanted my answer x plus 6 to equal 0, then I would need to plug in a negative 6. So if I went one more, that would give me 0. So my graph is looking like that. So it's starting at negative 6 and curving to the right. So I want to see which one of these images matches. So if you look at each of these, this one starts up in space, but R started on the x-axis. This one is curving to the left. C appears to be the only one curving in the right direction, and D starts on the wrong side of the y-axis. So C is going to be our best choice here.